video, what I'm going to do is just kind of break down the circle notes that I posted on Google Classroom. Those of you who were able to come to class last week, you got a paper version of this. And if you didn't get one, there's a PDF of it under our interactive notebook pages section in Google Classroom. Okay. So when you look at this graphic organizer, it goes through the four main concepts related to circles. So you have diameter, which I gave you the definition right here, and here's an image of it. So it's essentially just a segment that goes straight through the middle of a circle, so it's center, and it splits the circle in half. We have the radius, which is always a point on the circle and it stops at the center. The area. So if you notice in this graphic organizer, the inside is shaded gray. That's to show you that area is the inside. And we have circumference. And I put the circle in bold because circumference is the distance around a circle. Okay. Another concept related to circles that I wanted to highlight was this idea of pi. So on the bottom, if you notice, it asks, what is pi? When we talk about pi, what we are essentially talking about is this number, this irrational number, meaning it's a decimal that never terminates. The decimal can go on forever and ever, and it never. Still don't know what the last digit of pi is, because essentially that last digit doesn't exist. It infinitely keeps going. That's the definition of an irrational number. All it is a ratio of a circle's circumference its diameter. And what that means is that no matter how large or how small a circle is, if I take the length around the outside of the circle and I divide it by that diameter, I'm always going to get pi. I'm always going to get 3.14, and digits keep going. You could test this out with any circle and you'll always get pi when you do that division problem. That's also why I put this little note on the top left. I put pi is approximately, so that's what the squiggly line means, is approximately 3.14. Since we don't know what the last digits of pi are because they don't exist, right? A lot of people just use this as an estimate. Okay, so whenever you use 3.14, know that you're not giving me an exact answer. All you're doing is giving me an estimate of what your value is. Okay, so yeah, the four main concepts in this idea of pi. Let's look at each concept just a little more in detail. So I give you all these characteristics regarding diameter. These two formulas that I'm gonna star right here is the formulas that you could use if you need to solve for the diameter. So this first one, if you know the circumference, or a problem tells you a circle's circumference is a specific value and it wants the diameter, all you do is take the circumference, divide it by pi, and you get the diameter. Similarly, let's say a problem gives you a circle's area. What you're going to do first is do the area divided by pi, and then you find the square root of that number. Once you find the square root of that number, you multiply it by 2 to give you the diameter. Okay, so here's the image of the diameter. I give you an example of how to get the diameter if you're given the radius. And most of the time, this is the kind of calculation you'll need to find to get the diameter. Oppositely, this idea regarding the radius, and I gave you two formulas to help you solve for radius. If you're given the circumference, one if you're given the area. And I give you this note of what it means to keeping your answer in terms of pi. We already talked about how keeping it in terms of pi makes it exact. And then if I have pi equal 3.14, that makes it an estimate, right? So let me show you examples of that. In the area formula, I tell you it's pi times the radius squared, or it's 3.14 times the radius squared. This, when I do the calculation on this second row, this is the exact answer. This is what it means to keep it in terms of pi. If I use 3.14 in my calculation, then all that is an estimate. Okay, and this first illustration, this is how you get an area if given a radius. My bad again. This pen is acting weird. So given radius. And the one below is how you get area given diameter. And I won't go through each step of my calculation because you could read through the steps that I wrote out. But as you see in both examples, I box the exact answer and I circle the estimate. It doesn't really matter which answer you give me. So if you want to keep it in terms of pi, that's fine. Same thing if you want to estimate. I just say look at what the directions are asking. If you're doing the Khan Academy practice, you'll see in the question whether or not it asks for an exact answer, or it's an estimate if they say round to the nearest tenth or round to the nearest hundredth. If you're not given specific directions about it, I'll let you have the liberty to choose. Do you want to do exact or estimate? Okay. And then the final term on this graphic organizer is the circumference. The formula for this, there's actually two formula. If you're given the radius up here, it's 2 times pi times radius. But if you have the diameter, it's just diameter times pi. And if you notice, it makes sense that there's two formula for this, because if diameter is twice the radius, all I have to do is multiply the radius by 2. This example up here is given the diameter, so I would just use this formula. So this is given diameter, and then the one on the bottom is given the radius. So you could use either formula for circumference, just depending on what the problem gives you. Okay, but essentially these two calculations, getting the area and getting the circumference, they're just multiplication problems. The only time where you should ever find yourself using division is if you're solving for the diameter or solving for the radius. Okay, please let me know if you have any questions. Shoot me an email, and I hope you guys stay healthy and safe.